Alright, so this program is going to look at this StringUtil. This would be, I don't know if you would see something this difficult on the AP test, but it's definitely an FRQ type question. It might look similar, alright, so it's probably a good idea we write these hard ones together, and then, you're good to go on the actual AP test. So anyway, it's called StringUtil. It says, consider the following incomplete StringUtil class declaration. You will write implementations for the method listed in this class. So you got StringUtil. So we'll write this. I'll write this right here. So let's do file, and then I can copy everything in. So main project. And I'll call it I'll call it main string util. Just make sure. String util. Okay, cool. I'll finish that. And create new. We'll call it string util. And I'll clean up a little bit here. Okay, so basically going to copy this method right here. And I guess I'll put that in as well. Copy and paste. I like putting mine right there. Alright, so let's read about what we're doing here. It says, write the StringUtil method APCSA replace all, which examines a given string and replaces all occurrences of the designated substring with another specified substring. And write in your solution, you may not use the replace all, or replace first methods in the Java string class. So these aren't a part of, these are, you could learn these on your own, but these aren't a part of the AP subset, so don't worry about them. You're not allowed to use them. The following table shows several examples of the results calling StringUtil APCSA replace all. Okay, so you've got an original string that's to be or not to be. The old string it wants you to find is the TO, and it wants you to replace with the number 2 so that it spits out the number to be or not to be. Each occurrence of 2 in the original string has been replaced by the number 2. Advanced calculus. Okay, the advanced calculus string, the old string's math. Is math in here? No. Can we replace math, which doesn't exist, with science? No, so it just returns the original. We got go, go, go. The old string is go, so then we got to replace it with gone. Now this becomes an issue because isn't go in gone? So if this is go and then it becomes gone, go, all right, wouldn't it then replace the G right here with another gone? And so on and so forth. So that will not work. You got to make, we're going to have to make sure we put something in here that makes sure that once we're past this point right here, we go to the next one and we don't just keep doing it over and over and over again. And then we got AAA, so the old string 3 A's, and replace it with a B, so it would come out like this. So this is the biggest issue in this, okay? You have to make sure that you find the original one, and then your next index would start here, with what you replaced it with, and not go back to the very beginning. So, because we're going to definitely use a while loop. So anyway, let me set up my main and do a bunch of these. So I'm going to do StringUtil dot my I don't know. Let's just do this. Let's call it test1. My equals new string util. Okay, and then how many tests were there? Were there 4? 1, 2, 3, 4. Yep. Okay, so then we'll do test 2, test 3, test 4, test 5. And there wasn't 5 in there, so that's cool. Okay, so then we could say test1 dot, and then this thing's going to replace information and spit back the string. So what is it going to return? It should just return the new string. Let's see this. str. Okay. You know what? Forget that. Okay, so then I do str equals to be or not to be. The old str is equal to to. Then we got the new str. So replace all, and I pass in str, old str, and new str. Okay. And I want to do a system.out.println to get that returned. And I'll just do that for each of these, okay? This one will be test 2, this will be test 3, and this will be test 4. Okay. This needs to be advanced calculus. Alright, I need to change this from to be or not to be for the second test to that. Why is it doing that? Okay, so I guess I just need to type it in. Advanced calculus, math, science, go, The old string is go, and the new one is gone. And the last one is 1, 2, 3, 4, 5. And we want to do triple A's and replace that with a B. All right, so this would set up our test environment. And there's going to be an error if I ran this because we have to return the string here into here for each of these. So, but that at least sets up our main so we can run this thing and test it. So inside here, so what I'm going to do is create a two different strings. String what's left, and I'm going to set that equal to the string. And then I'm going to do replaced, and that's equal to a blank. And I'll show you why here in a second. So first thing we need to do is we need to do a while loop. And we need to check and see if the old string is inside here. And if it is, where is it at? Okay, so while what's left, so that's equal to our string. And again, the reason why I created this is because I want to keep my original string. I don't want to overwrite it. So I just create a new variable called what's left. And so anyway, what's left dot indexOf will pass in the old string. And if it's there, meaning it's greater than or equal to 0, or you could do it, say, if it, as long as it's not equal to -1. Either way is fine. Basically, it finds the string at either position 0 or anywhere else in the string. If it finds, like, I think it's 2, the word 2 inside here, then we got to get rid of it, right, and replace it with the number 2. Okay, so it finds it at position 0 here. So replaced is going to be equal to what's left dot substring at position 0, comma, what's left, the old string. Okay, so 0, sorry, I need indexOf dot indexOf. Okay, so if it's there, if the word to is inside to be or not to be, we start at 0 and then we go to the index where it's at. Okay, in this case it's at position 0, so it's actually going to give us a blank right here. Okay, because it's at the very first position. So this would be 0 and this would be 0, and 0, 0 gives us just a blank spot. So that would be replaced, would be blank. Okay, so then what we can do is we can say replaced is basically blank right here, all right, after we run this. Replaced is blank, all right. So then we can do replaced plus equals the new string, which would be the number 2. So now we got, this is basically 2 right here, okay? And probably want to do that. Then we can do replaced again. Sorry, we can do what's left equals what's left dot substring, and then we've got to do from the end of the old string plus the length of the old string. So we need to find where it starts and then go to the end of the old string. So it starts at 0, 1, and then 2 at position. So the length of this is 2, so 1, 2. We need to start right here to get the end of this. So we don't want to keep this on here. Okay, we want to yeah, let's look at this real quick. So let's just write it out, and now I'll hopefully make a little bit more sense. So what's left dot index of with the old string. So that's going to give us basically 0 here. Okay. And this needs to be a plus the old string dot length. Okay. So 0 plus the length is 2, so that gives us what's left. So that's going to give us this blank spot, be or not to be, because remember, you know, if I put this in here, this is index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7. Okay, so if the length is 2, 0, 1, 2, that's right here. So we go from position 0, where it first finds the TO, 0 plus the length of 2. This whole thing is equal to 2. So we're doing what's left is this this section right there. All right. So that gives us what's left of our sentence. Okay. Now remember, we had replaced being the number 2. Okay. So we look to see if it's in here again. It is. It's at this position. So we're going to take 2 plus what's left, which was this, and we're going to add it into it. Okay. So let's, I think this is basically done. I mean, the algorithm in my mind works. Let me see here. Sorry, my computer just kind of shut down. There we go. Okay, so plus what's left. Okay, so let's see if this works. To be or not to be, advanced calculus, gone, bah. All right, cool. So it does work. All right, so again, and what I'll do, I actually have the answers written out here, but I actually go through, you know what the length of this thing is, and I go through each one step by step. So the first time going through this while loop, replaced as blank, then you got a 0 and 0. That gives us blank. So blank plus, and then we want to add in the new string of 2. So this becomes 2. And then what's left here is be or not to be. So maybe this worksheet would help you kind of go through each loop. So what's left then is that. This gets passed into here. Okay, what's left dot index of, if it does it find the old string of 2? Yes. So you've got replaced, which is 2 from up here from the first loop, and then you've got let's see here, we want to go from be or not to be. So this gives us what's left dot index of 2, so that finds it at position 11 right there. So we want to go from 0 to 11, which would give us this string right here, and add it to the original replace, which is then to be or not to, or sorry, to be or not. And then we want to add in the new string of the number 2. And then what's left is just going to be, the old string plus, you know, where we're at here, which is 11 plus 2, which is 13 up here. So it's blank and then B. And then we run it again. What's left is that. The third time through, it does not find the word TR2 or TO in here. So then all we do is just add on what's left to the what we replaced. So we basically are just rebuilding your string with this replace and adding what's left to it. And as you can see, it you know, it spits out the proper answer at the end. All right. So anyway, study this one a bit. If you can get this done, you'll be really golden for anything that the AP tests, any sort of string problem. So